Hello and welcome, students. Let us discuss this paper, this geography optional paper, which was there in your first test. So, the first question is compare Davis' geographical cycle with Penck's model of landscape development. So, here we have to compare the Davisian cycle with Penck's cycle of landscape development, which is related to slope evolution or basically the study of the slope. So both of them, William Morris Davis and William Penck, they studied the evolution of the slope, but their approaches were different because one was geomorphologist, another was geologist. So basically, Davis was geomorphologist and Penck was geologist. So if we look into this aspect, then definitely their approach would have been different because William Morris Davis, being a geomorphologist, his focus was more on the exogenic forces. That is the formation of the landforms because of exogenic forces. Whereas William Penck was geologist and his focus was more on the interior of the earth or the endogenic forces, that how these landforms are being created. So here in the introduction itself, we can write that their approaches were different, and we can write about these forces that endogenetic forces create, but exogenetic forces modify. So definitely there was modification of the landforms or slope evolution was there, but the approach was different. How this approach was different because Davis was following the slope decline theory. So his approach was of slope decline, whereas Pang's approach was of slope replacement. We'll look into this aspect, that what is slope decline and what is slope replacement. So basically, how let us look into how William Morris Davis started. So according to William Morris Davis, initially there was a flat surface, and then there is sudden upliftment. So this itself was a erroneous assumption from William Morris Davis' point of view, that the upliftment is very sudden because of the endogenetic forces. And then the erosion proceeds under prolonged tectonic stability, meaning he's saying that after a sudden upliftment, there is stability, that is, no endogenetic forces is acting, so no further upliftment is happening, and then there will be start of the exogenetic forces or the start of the erosion. And then he suggested that landform will pass through various stages of youth, maturity, and old. So before coming into these stages, you need to suggest that he was basically suggesting that the upliftment is sudden, and there will be stability. Only after that there will be erosional activity. That is the erosional activity will pass through various stages, and the processes which he suggested was the role of erosion and deposition in. So basically he was looking into both erosional and depositional aspect as far as shaping of the landscapes is concerned or the shaping of the slope is concerned. So obviously in the youthful stage, what will happen? There will be more increase in depth as compared to the increase in width, because erosion processes such as fluvial or glacial action are dominant, and this leads to the formation of distinctive landforms. And as the landform matures, depositions become more significant. So we can take example of river here. We can take the example of Ganga here. What he was suggesting as far as this erosional landform is concerned, he was saying basically that, let us take an example of Ganga. That when Ganga is rising from Himalayas, it is basically passing through the gorges. It is an antecedent river, right? So it is passing through various stages. In youthful stages, the valleys are deep, V-shaped valleys are there. Whereas if we look into the senile stages or the old stages, then what is happening? There is more deposition. There is formation of deltas as far as the old stage of Ganga is concerned. So similar thing was suggested by Davis, that erosional and depositional factors are acting, but they are acting after a period of time, and also they are acting in different intensity. In the initial stage, the deep cutting is happening, whereas in the later stage, the deposition is more. Then he also gave the concept of equilibrium, that is dynamic equilibrium, where landscapes tend towards a balance between uplift and erosional processes. So basically, this is regarding relative stability only, that endogenetic stability has been achieved, and only after that external forces starts acting. But as far as Pank is concerned, William Pank was a geologist. So his focus was more on endogenetic forces rather than exogenetic forces. So he suggested that any slope found anywhere can be divided into number of smaller straight slopes. So he basically gave the concept of parallel retreat. And before that, when he said that there will be formation of, if you look into the basic aspect of Pang, then he said that initially there will be primer oomph. Primer oomph will be a flat surface, and then there will be upliftment, and then there will be erosion as well. So endogenetic forces and exogenetic forces will go hand in hand. Whereas in Davisian cycle, what we saw, that initially first there will be endogenetic forces, there will be stability, then only exogenetic forces will act. Whereas here he is saying that both endogenetic forces and exogenetic forces will go hand in hand. Along with this, what Pang said, that there are two types of slopes. The slopes are not similar. There are steeper slopes and there are gentler slopes. So he used various German words as well for this. For steeper slopes, he used the word Boschestilwand. Boschestilwand for steeper slopes. And for bottom gentler slope, he used the word Heldenhang. Heldenhang. So this is the Boschestil one, because this is steep, whereas this region is Heldenhang. This is comparatively bottom slope and gentler slope. So let us look into the landscape development here as far as Planck model is concerned. So he suggested his focus was on influence of tectonic forces, particularly upliftment and subsidence in shaping the landscape. Now the model includes stages such as uplift, peneplain formation, and then rejuvenation. So that is a continuous process. It will not stop over a period of time. Cyclical erosion will also happen. So this was cyclical model. Both the models were cyclical, but here he talked about that various cycles will happen. Then he also focused, his emphasis was in tectonic activity, that is endogenetic activity. We already saw that he was a geologist, and hence his focus was on tectonic activity. And his model emphasizes on the dynamic nature of landscapes in response to tectonic forces. And also, there was a similarity as far as Pank's and Davisian model is concerned, because similar to Davis model, Pank's model also considers the concept of dynamic equilibrium, where landscape adjusts to changes in tectonic forces over time. So all the processes are happening, but only difference, the first difference which we can see is in in Davisian case, if we have to draw a diagram, let us draw a diagram, because we have to draw a diagram in the examination hall as well. So if we draw this diagram of various stages of Davis model first, then what Davis is suggesting, that first initially upliftment is happening, and as far as upliftment is happening, there is no erosional forces acting here. But then suddenly there will be erosional forces, and when erosional forces are happening, there is deep valley cutting. Then this is youth stage. Then in mature stage, valley widening will happen. So this valley widening will happen. And over a period of time, what will happen? An end surface will emerge, which will be comparatively flatter surface. And this flat surface will be termed as penny plane. This is Davisian model. Okay. But if we look into the Pank's model, then in Pank's model, again, let us draw various stages. So he said that while upliftment is happening, at that period of time also erosional forces are acting. And then again similar scenario that there will be deep valleys as far as the young and mature, comparatively deep valley in mature stage, but widening will be more. And then there will be end flat surface which will be end roof. So he gave the concept of prima roof and end roof, and end roof is new prima roof. Basically, in prima room there was a flat surface. In end room also there is again a flat surface has emerged because of erosion, and again there will be upliftment. Again there will be a cycle of erosion. So now let us look into the comparison of Davisian and Planck's model. So Davis model focuses more on erosion and deposition process, while Planck's model emphasizes more on tectonic forces such as upliftment and subsidence. If we talk about the temporal perspective, then Davisian model is more linear and sequential with distinct stages of landscape evolution. This we already saw. That various stages are happening, where in the first stage, Davis is suggesting that no exogenetic forces is acting, whereas in Planck's model, there is more cyclical approach where tectonic activity and erosional activity or the exogenetic activities and depositional activities are going hand in hand. As far as the landscape change is concerned, so drivers of landscape change are various processes, and Planck highlighted the influence of subsurface tectonic forces in shaping the landscapes. And processes, if we talk, then obviously it is a complex interplay of both internal and external forces in shaping landscapes. Okay, but the emphasis was more as far as Planck's model is concerned. So Planck's model said, if we see this diagram again, that slope here, if we look into this slope, let us take an example of this steeper slope. So a steeper slope will erode faster as compared to the gentler slope, right? And but there will be replacement in similar fashion as well. So this slope will replace after erosion. So there will be replacement over a period of time. So Planck's model, if we go towards the end, then Planck's model is more acceptable as compared to Davisian model, because Davisian model is basically unique. It has a special and uncommon characteristic. Only few cases can be seen as far as Planck's model is concerned, as far as Davisian model is concerned. Whereas if we talk about the Planck's model, then this model can be said as generalized model. So, and Planck's model was also strengthened over a period of time because of, with the example of antecedent rivers. That antecedent rivers form deep gorges and canyons, and we have seen the example of Himalaya, we have seen the example of Ganga. So, this can happen as far as the Planck's model is concerned. So, in this answer, although the material provided is very huge, but you need to focus that both the model talked about the erosional and depositional and upliftment. So basically endogenetic and exogenetic forces, but their approach was different because one was talking about the slope decline process, where was another was talking about the slope replacement process. You can provide examples as well. You can provide example of antecedent rivers. You can provide examples of Ganga, for example, in India's case. So like that, you can, along with example, use the keywords and write this answer, and you can draw this diagram as far as comparison is concerned. Now let us look at this second question, that is the compare and contrast tropical and temperate cyclones. Now the question is for 15 marks and you have to write it in 200 words. So basically we know that tropical cyclones and temperate cyclones have different characteristics. They have different origin story, they have different type of impacts as far as the human settlements or impacts on the climate is concerned. So you have to attempt the question as well in similar format. So now let us look into the answer. Firstly, as far as the origin is concerned, so tropical cyclone has thermal origin, that is, it is dependent upon the temperature, whereas The temperate cyclone has dynamic origin. It depends upon the movement of air mass, frontogenesis, and Coriolis force. So here we need to bring fronts. Front formation is very important as far as the tropical cyclone is concerned, because different stages of front formation happens as far as tropical cyclone is concerned. So firstly, there is front formation, which we term as frontogenesis. Then there is formation of occluded front, in which one front gets uplifted, and then frontolysis happen as the tropical cyclone ends. As far as the location is concerned, then tropical cyclone has is usually happens at 10 to 30 degree north and south of equator. Here also Coriolis force is important. For the formation of tropical cyclone, Coriolis force is very much important, because we know that in tropical cyclones, first there should be extreme heating in the water body, that is 26 to 27 degrees sea surface temperature is required. The surrounding area has comparatively high pressure belt. Then the air flows in the direction of high pressure to low pressure. And because of Coriolis force, there will be rightward bend as far as northern hemisphere is concerned. So if rightward bend starts, then we know that there will be anti-clockwise rotation. So it rotates around the common axis, and hence a spiraling, whirling movement starts in case of temperate cyclone. Tropical cyclone. Whereas in case of extratropical cyclone or temperate cyclone, there is formation of front, that is cold front and warm front. Usually, cold front and warm front form an angle. Cold front is faster, it uplifts warm front, and hence occlusion happens. Once this occlusion happens, we know that there is formation of temperate cyclone. Also, we need to know the characteristics of cold front and warm front. Cold front is faster, it is denser. Here we know that comparative, comparatively rainfall is higher in case of cold front. Whereas in case of warm front, since the slope is gentle, so the rainfall or the cloud formation is comparatively gentler. Whereas in case of cold front, it has comparatively steeper slopes, and hence the rainfall is higher. As far as latitude is concerned, we know that from 0 to 5 to 7 degree north and south of the equator, there is absence of Coriolis force. Hence, the tropical cyclones are also absent in this belt. So usually we observe tropical cyclones in the range in the latitude of 10 to 30 degree north and south of equator. But also it is more prominent in tropical cyclone. There was one question in prelims as well, that usually the cyclone formation happens in the northern hemisphere. So it happens in northern hemisphere. Usually, it also happens in southern hemisphere, but usual dynamics is related to northern hemisphere. As far as temperate cyclone is concerned, the belt is 35 to 65 degree north and south of the equator, and more pronounced in northern hemisphere also, because of greater temperature contrast. Now, why greater temperature contrast is there in case of northern hemisphere? Because of land sea differential. So land sea differential is there, more land mass is there in northern hemisphere, hence land sea differential is also there. As far as frontal system is concerned, we know that this cyclone is formed because of frontal system, temperate cyclone, whereas in case of tropical cyclone, it is absent. We have already seen the temperature requirement, 26 to 27 degrees Celsius. And also one very important thing is, it originates in sea only, whereas temperate cyclone originate in both land and seas. The season is late summers, that is August to October. Why it happens in August to October? Because by the month of August, the sea surface temperature is adequate enough to form tropical cyclones. Now, as far as August is concerned, there is one news. In 2024, there was one rare cyclone in the month of August in Arabian Sea. You must know the name of this cyclone. This was a very rare phenomenon, because in the last 100 years, only 4 cyclones have been observed in the month of August in Arabian Sea, and the name of the cyclone was Cyclone Asna. So you can use this example, Cyclone Asna, from the recent phenomenon. As far as the temperate cyclone is concerned, it is irregular, but it is more pronounced in winters, and this cyclone brings western disturbance or winter rainfall in the northern belt of India, that is in the Punjab, Haryana, Western UP belt, and because of which Rabi Fasal is also it is beneficial for the Rabi Fasal. As far as size is concerned, then tropical cyclone is limited to a small area. That is, it has a diameter of 100 to 500 kilometers. The eye of the cyclone has a diameter of around 10 to 20 kilometers. Whereas if we talk about the temperate cyclone or extratropical cyclone, then it covers very large area. Why? Because the front covers very large area. Both the cold front and warm front, they cover very large area, and hence it covers around 300 to 2000 kilometers in diameter. Now, as far as the shape is concerned, usually the shape of the tropical cyclone is considered as circular. If we talk about the eye, it is nearly circular. But if we take the example of whole cyclone, and if we take the satellite view of the cyclone, then we can see that it is elliptical in nature. So you can either write circular or elliptical. It is not wrong. And if we talk about the temperate cyclone, then it has inverted V shape. Here you can see that this blue color is depicted by cold front, and it is basically fast. It is overtaking this warm front, and once it overtakes the warm front, it totally uplifts the warm front, and at that place occlusion happens. Then if we talk about the rainfall is very heavy for few hours. At least it is very heavy, and IMD also issues cyclone warning as far as cyclone is concerned. So it there are four stages of cyclone warning, like pre-cyclone watch, post-landfall watch. This kind of notification is being provided by IMD to all the coastal people through radio, through satellite, through messages. If we talk about the temperate cyclone, then rainfall is slow and continuous for many days, sometimes for weeks, whereas here it is for 2 3 days majorly. If we talk about the wind velocity, then wind velocity is very high as far as the tropical cyclones are concerned. In case of super cyclones, it may reach up to 400 kilometer per hour. Okay, so this is a very gusty wind. So it causes greater destruction because of its wind speed, storm surges, and torrential rains. Whereas if we talk about the wind velocity of temperate cyclone, then it has comparatively low speed and hence less destruction, less flooding, and more beneficial as far as rain is concerned, winter rain is concerned, whatever water is required for the agriculture, that is being provided by tropical cyclone. If we talk about the isobar as well, then complete circles are being formed. Isobars are basically line joining similar pressure. So isobars are complete circles as far as tropical cyclone is concerned. In this case, it is V-shaped. We already saw this. This is the zone of isobar. Here we made the isobars only in low pressure area. If we talk about the lifetime, then we saw that the lifetime of the tropical cyclone is very less than a week, whereas the lifetime of the temperate cyclone is 2 to 3 weeks. If we talk about the path, then it is east to west. Usually you can take the example of Bay of Bengal region, that most of the cyclones, they originate in the Bay of Bengal and they do their landfall or they move towards the eastern coast of India. You can take the recent examples of various cyclones that hit the eastern coast of Odisha, Andhra Pradesh, and Tamil Nadu. You can also take example of some of the major super cyclones like Cyclone Fani, Cyclone Philene, which caused massive destruction in this region. So along with path, you can provide examples because examples substantiate your answer. So examples are very much needed. If we talk about the temperate cyclone, then here the path is west to east direction. And why west to east direction? Because of the westerly jet streams and they move away from the equator. So this is because of the jet streams if we talk about the path of the temperate cyclones. So all these points are needed as far as the comparison or contrasting of temperate and tropical cyclones are concerned. Temperature difference is also very huge, is almost equally distributed as far as temperature difference is concerned. All the sectors of the cyclone have different temperatures if we talk about the temperate cyclone zone or extratropical cyclone. If we talk about the calm region, then we already saw this was a again question in prelims as well, that the calm region of the cyclone is basically eye of the cyclone. It is comparatively very calm. If somebody is in the center of the eye, they will not encounter cyclone. And the most devastating region is eye wall. So eye wall has the highest wind velocity, highest amount of rainfall, whereas eye region is the calmest region. And in case of temperate cyclone, there is no such region of inactivity. All the region across the front has a fair amount of rainfall. So, and the driving force, if we talk, then the driving force of you must prioritize this point, driving force. After sea surface temperature and all, that is thermal origin, sea surface temperature, you must prioritize this point, that the driving force in case of tropical cyclone is latent heat of condensation, whereas in case of temperate cyclone, it depends upon the density of air masses. So this is what is needed as far as tropical cyclones and temperate cyclone is concerned. This point you can avoid because in case of cyclones in Bay of Bengal, you can see the impact of TEJ, that is tropical easterly jet stream, because tropical easterly jet stream steer the cyclones towards the coast, whereas in case of temperate cyclone, jet streams are very prominent because they flow in the direction of jet streams only. So that's why jet streams, Rossby waves are important as far as the temperate cyclones are concerned. So like this, you can attempt this question. These points are not needed if you have to write in 200 words. If the question is of 250 words, then you might add these points, but not much needed because you have already covered the clouds, that cumulonimbus clouds are being formed as far as tropical cyclones are concerned. Here the clouds are not in the form of cumulonimbus. Here the clouds are usually nimbostratus, or in some cases cumulonimbus clouds are also created, but not of that intensity. So this is what is required as far as the comparison of tropical and temperate cyclone is concerned. But one very important point is needed towards the end, and that is impact on humans. Its impact is very much needed as far as the end is concerned. Example is very much needed. You have to substantiate the answer with examples, as well as impact is needed. Here it is devastating. It has devastating impact. Whereas if we talk about the temperate cyclone, then temperate cyclone brings fair amount of rainfall. It is helpful as far as agriculture is concerned. So this is how you can write about the impact towards the end of your answer. You can end the answer with the impact only, and you can end the answer with respect to cyclone warning system as well, IMD cyclone warning system as well. Because of the devastating impact, we have developed cyclone warning system, and here you can give example, or you can add case study. If suppose any question comes only related to tropical cyclone, then you can add a case study of Odisha State Disaster Management Authority. This was given in World Bank as well. World Bank used it as an example that how Odisha dealt with the tropical cyclone after the super cyclone of 1999, in which thousands of people died. So what Odisha State Disaster Management Authority did was they basically created a robust system in which there was a focus on cyclone warning system, there was a focus on preparedness. Each and every uh, local panchayat was connected as far as the season is concerned, season of cyclone is concerned, that is August to November. And one more important thing you can see in this year's cyclone, when recently one tropical cyclone hit Odisha coast, then the health authorities were already prepared because there were 4 5 women who were pregnant in our local panchayat. So they already shifted them to the wards 4 5 days prior to their due delivery date. So that is the level of preparedness, that they were already contacting the people that there is a possibility of landfall as far as tropical cyclone is concerned. So like this, you can link the preparedness aspect if a particular question comes related to tropical cyclone. But otherwise, if you have to compare and contrast, then you can add 6, 7, 8 points and you can substantiate it with example. Now let us move into the third question, which is a very direct kind of question. That is a combination of direct and indirect sources of information allows geographers to infer about the structure and composition of the earth. Basically, you have to talk about the structure and composition of the earth. In structure, you will talk about the layered structure. In composition, you will talk about the material. So you must have read this direct and indirect sources of information in the interior of the earth. In GS also, this is very much important. This is very much GS kind of answer. So here, basically, you can divide your sources of information about the interior of the earth. So direct or observation. And how we do direct observation? By observing the trench area, the boundary area. Boundary means tectonic plate boundaries like convergent boundary, divergent boundary, or transform boundary. So this by this you can look at the crustal region of the earth or the lithosphere of the earth. But this knowledge is limited. As far as direct sources of information is concerned, this is limited. If we talk about scientific drilling experiment, then this is also limited because we have only drilled so far by 12 kilometers. That is, our deepest drill is of 12 kilometers in Kola Peninsula, Kola super deep borehole in Russia. So Kola Peninsula is the deepest drill we have done. So our information related to drilling is limited. Why this is happening? Because as we as we move towards the interior of the earth, then we have observed the temperature increases exponentially, and we do not have that much technological expertise as far as the drilling is concerned. So that's why we can write about that it is limited. Our drilling experience is limited. If we talk about the evidences based on temperature, then we can give an example of basin and range area of USA. Here we have observed that there is difference in temperature because normally we used to think that rate increases by 1 degree Celsius per 32 meter as far as the descent is concerned. But when we moved towards the depth of 50 kilometer, we saw that the temperature would have been 1200 to 1800 degrees Celsius. And at this depth, the Earth would not have, because if we go by this rate, then if we move towards the core, then the temperature would reach up to around 25,000 degrees Celsius. And if this 25 degrees Celsius happens, then Earth will melt. Okay, so that's why the evidence as far as temperature is concerned is also limited. If we talk about the evidence based on density, then here also we know that if we talk about the density, then the average density of the earth is 5.5 gram per centimeter cube or per cubic centimeter. One very important thing is you need to mention the units as far as the density or uh, this any figure if you are providing, you need to provide it with unit. Okay, so you must write 5.5 gram per centimeter cube. Otherwise, what is 5.5? So you need to provide gram per centimeter cube. So we know that sedimentary rock has average density of 2.7 gram per centimeter cube. Whereas if we move towards the core, then it is made up of knife, that is nickel and iron. So it must be of a range of 11 to 13 gram per centimeter cube or 11 to 14 gram per centimeter cube towards the center of the earth. Then you can write about the pressure, that as we move towards the center, then the superintended load will increase. And as this superintended load will increase, there are chances of crumbling of rocks. Had the earth would have been made up of only rocks, then rocks would have crumbled, because all any rocks have limited carrying capacity. It has a critical limit that a rock can be compressed up to a limited critical limit. Beyond that, the rock will crumble. So we deduced one thing that okay, the interior of the earth is not made up of rocks only. There must be presence of some heavy metals like nickel and iron. So like this, we saw that the concentration of nickel and iron is there. Then on the basis of volcanicity also we know that what all materials are there, because if suppose magma is coming out in liquid form, so we know that mantle is made up of liquid, because we know that magma is coming from the this layer mantle or outer mantle. So if magma is coming from outer mantle, then from what depth it is coming, on that basis only we can say okay, it is made up of different material, or what is the concentration of material. So on that basis also we can tell that this can be used as a evidence as well. Then evidence of seismology. Evidence of seismology is basically P waves and S waves, the body waves. These are this is one of the most important point as far as indirect sources of information is concerned. Because if we talk about the indirect sources of information, then the thing which we noticed in P waves and S waves, here you can make the diagram of P waves and S waves as well. Because we saw various phenomena, like we saw diffraction or refraction because of change of material. We saw shadow zone, and on this basis we saw that one layer is liquid, another is solid. Because P waves is a primary waves, it is of longitudinal nature, and longitudinal nature means it moves in the direction of energy, that is there is to and fro motion. Whereas S waves are shear waves or secondary waves, and shear strength happens in case of solid, so S wave travels only through solid. So wherever S waves is traveling, it means there is presence of solid. Whereas through diffraction also we saw that there is change in density, because if density is changing, then there is diffraction. So on this basis we knew about the, or we deduced about the interior of the earth. So these are the, this was quite a straightforward question where you have to tell which is the direct source, which is the indirect source. So if we talk about the direct sources, then direct observation and drilling experiment is the direct source of information. Volcanicity is the direct source of information. But if we talk about the indirect sources, then temperature also can be said that it is a indirect source. Density we deduce from P and S waves, indirect source. Then seismology is an indirect source. So these are the indirect sources of information as far as the interior of the earth is concerned. And towards the end, you can say that still we do not know completely about the interior of the earth, and through technological improvements or through the advancement in science related to geology, we can know about the interior about of the earth. Now the next question is again related to karst topography or landform. So let us look at the question, that is discuss the role of underground water in shaping karst topography. So you need to focus on this underground water, because we know that karst topography is basically limestone topography, and limestone is soluble in water. So there is basically solution, there is basically a reaction, because of which there is formation of different kinds of landforms. And these landforms are combinedly known as, guess the word, because there was a question in 2019. These landforms are combinedly known as spleothems. Spleothems. So there was a question in 2019 optional, that what are spleothems? Now, why this question was asked? Because this, the reason is also important, that why it was asked in previous as a previous year question. So there was a major event happened in the in Thailand, in Chiang Rai province. In Chiang Rai province, basically 18 footballers were trapped in a cave, in a limestone cave, and there was a rescue operation. They were rescued successfully by the Thai special forces. So it was very much in news as far as this topography is concerned. So that's why it was asked. So you can use this as an example in this Chiang Rai province as an example as far as karst topography is concerned. So let us look into the question now. That underground water is under, underground water is very much important as far as shaping the karst topography is concerned, because the primary agent responsible for the formation of different features of karst landforms is basically chemical weathering. So here weathering happens, that too of chemical nature. This chemical weathering is basically solution. That is, the chemical reaction happens because of which there is dissolution of rocks, limestone or dolomite or gypsum. Okay, so because of this dissolution, the karst topography is being formed. Now let us look into the dissolution process, because we have to discuss the role of underground water. Underground water, here we can use aquifers or any water source that is available in the beneath the earth. So if we talk about the dissolution process, then the basic dissolution process is weak solution of carbonic acid. You can directly write this point, that there is a weak solution of carbonic acid. This carbonic acid reacts with calcium carbonate, and this breaks down the calcium carbonate or limestone, and then calcium bicarbonate is being formed, which is soluble in water. And this dissolution basically forms different types of landforms. So you can name different types of landforms. You must have seen the stalactites or stalagmites or calcite pillar. Like this, you can write about the or sinkhole. So these are the various landforms as far as karst topography is concerned. So you can add these things. Now, after a dissolution process, you can write about the cave formation and development. So why cave formation happens? Again, because of dissolution it happens. So voids are being created. These voids gets enlarged and enlarged over a period of time because of dissolution, and joints and bedding planes and faults is being created, and also there is flow of underwater river as far as the underground water system is concerned in karst topography landform, because you can see the example of Chiang Rai province. There was presence of one underground river, which was going through the cave, and because of which there was entrapment of those players. Okay, so you can see here also that there is presence of channels, because of which there is formation of cave. Then there is formation of sinkholes or dolines. Sinkholes are basically because of the dissolution, a sinkhole is created. Recently, there was one news related to formation of sinkhole in the ocean as well. So you can take example of that as well. If the oceanic bed is made up of limestone, then also a sinkhole is being created. But usually sinkhole is being created in karst topography. Okay, so sinkholes are very common in this doline region or limestone rich region. Okay, so the cover collapses in sinkholes. Thick layer of soil or rock which is covering the cavity becomes unstable, and this collapses into the void. You must have seen various videos related to accidents because of the formation of sinkhole. Okay, then you can write about the underground drainage system, and usually this underground drainage system is complex because there are rivers, there are streams, or there are underground aquifers which acts as lake which form these kind of systems. So you can write about various, you can draw diagram of the cave as well. You can draw a diagram like this, that there are various stalactites, stalagmites present in the karst topography. There are present of calcite pillar as well. This is given in GC Leong as well, and then there is presence of underground stream along which there is, and you can label this diagram. Okay, so there is presence of a stream, there may be presence of some water body as well, aquifer as well, and because of this water there will be dissolution. Okay, so this is very important. Karst springs is from where the groundwater, after flowing through underground passages, emerges at the surface. So a spring is basically a surfacial phenomenon and not an underground phenomenon. So you can avoid this point, but you can say that if there was presence of any underground passages, then after a dissolution, it may lead to formation of spring. So like this, you can write this point. Then erosion and sediment transportation. Why this happens? Because of dissolution and because of presence of a stream. So a fluvial action happens, that is a flowing water or flowing stream basically carries the dissolved limestone or dolomites from one position to another position, and hence the erosion happens, and on another place there will be a deposition happens. So some are depositional landforms, some are erosional landforms as far as karst topography is also concerned, because deposition will also happen. If erosion is happening, then somewhere there will be deposition as well. Okay, so that's why it becomes important. Then karst, plateau, and tower karst, these are basically different types of topography only. You can add all this topography, but you have to focus on the major reason that why. Because see, you have to write this answer in 200 words. If you have to write this answer in 200 words, it means you will add one introduction, one conclusion, and you will basically write 8 to 10 points maximum, right? With subheadings. So your focus should be on underground sources. Then what are the different types of landforms that are being created? You can use some key terms like speleothems and various other uh, landform types. You can use examples. For example, one we already saw, Chiang Rai province. Another you can write about Krem Mamla cave. Now you must be knowing this Krem Mamla cave is present in Meghalaya in Khasi Hills, and after this cave only Meghalayan age is being named. Meghalayan age. So that's why this is important. So like this, you can attempt this question. Now let us look at the next question. That is the concept of level of compensation. Now, who gave this concept of level of compensation as far as the isostasis is concerned? So first thing we need to focus on is these two key terms, level of compensation and isostasis. So basically, isostasis is a condition of equilibrium. Okay, so how this equilibrium happens? Between a floating landmass and the asthenosphere. Suppose we know that asthenosphere is suppose this is an asthenosphere, then we know that it is a plastic layer. Now let us increase the load. If we increase the load over the asthenosphere over a period of time because of formation of land or because of formation of some body, then what will happen? There will be bending, there will be adjustment, there will be equilibrium. This will try to adjust the weight. As this bending happens, it will get into the level of compensation. Once this load is removed, there will be rebound. Okay, so this is basically the concept of isostasis. If you look at the definition of isostasis, then it is basically a condition of equilibrium where a floating landmass and the asthenosphere beneath them maintained despite the forces that tend to change the land masses all the time. Okay, so this principle of isostasis is basically based on the principle of buoyancy. And who gave this principle of buoyancy? Archimedes. Archimedes. It is based on the Archimedes principle. So all these things you need to write as far as the introduction is concerned related to isostasis, that it is based on the principle of buoyancy. It is about the equilibrium, that any weight, if any weight is being put at the asthenosphere, then what will happen? Now you will Before jumping directly into level of compensation, you must briefly discuss line of compensation. Now, who gave the concept of line of compensation? Pratt gave the uh, concept of line of compensation. And what was line of compensation? That different densities are there as far as the various relief features are concerned. So they are basically standing at a line of compensation, and their different relief features have different densities. For example, let us take an example of Himalaya. Himalaya is made up of sedimentary rocks. So sedimentary rocks must have different density, whereas the Deccan lava plateau is made up of basaltic rock. So basaltic rock must have higher density. So there will be different density, different relief feature, and hence there will be different line of compensations. This was the idea of Pratt. So you can briefly write about the background, background from where this idea of isostacy emerged. After this, you can write about the level of compensation, and level of compensation was basically given by two uh, geographers, that is Hefford and Bowie. It is better to mention these names because then only you can look here. Also, the relevance of Pratt's concept is given. So basically, Pratt's concept was line of compensation. Okay, and here you can see that different density is being mentioned here. But here Hayford, okay, Hayford, some of the material, it is some of the books, reference books, it is written Hayford. So Hayford and Bowie basically gave the concept of this level of compensation, and they talked about level of compensation instead of line of compensation. That there will be level where uniform pressure will be applied and above which there will be different densities. So this is very much true as far as physiography of India is concerned. And also Joly, also this Joly's concept of isostasy, who talked about zone of compensation instead of level of compensation. So Joly criticized Hefford and Bowie, and he supported the idea of Airy. Okay, that there is zone of compensation. So Joly insisted that different land masses will have different depths, but these land masses will be resting at zone of compensation, which is approximately around 15 kilometers or 18 kilometers thick. Okay, 15 to 18 kilometers thick. So this was the idea of Joly, 16-kilometer thick level of compensation. So this was basically a zone of compensation. Okay, so this was the idea of Joly. But one thing we must remember about isostacy is there was no one theory, not one theory which was clear or which gave the clarity about the isostacy, but rather a combination of theories was happening at different location. That is, different land masses have different depths of roots. We cannot say that all the land masses are similar. All the young fold mountains will have similar kind of isostacy, or all the plateaus will have similar kind of isostacy. So different land masses have different depths of roots. Then second thing was different landforms have different densities. This we already saw. Some are made up of basaltic rocks, some are made up of acidic rocks, some are made up of Sial, some are made up of Sima, some have heavy metals in them. So on this basis, there will be different densities, and this we already saw through this diagram. We can see, and here also we can see that some are made up of lead, some are iron, some are antimony, some are zinc. So definitely there is different landforms of different densities, and also the plates are able to share the load so that the downward adjustment is minimized. This is also a point, because it is a very important point, because earlier what we were considering as far as isostasis is concerned, we were considering this as thenosphere. But plates are also sharing the loads, right? As far as roots is concerned, so plates are also sharing the load. And also there is global isostatic adjustment. So that's why this process where isostatic equilibrium is restored is isostatic adjustment. And also one more thing you need to remember as far as isostasis is concerned, after talking everything about the level of compensation, you can say that Isostacy is not a static phenomenon, rather, it depends on erosion. It depends on anthropogenic activities as well. How it will depend upon anthropogenic activities? For example, China is building Three Gorges Dam, right? Three Gorges Dam it is being built by China, and it is one of the biggest dam. It is the biggest dam. So what will happen? A huge reservoir will be developed, and this huge reservoir will have load, and then there will be isostasy. So that's why this becomes important. So that's how we can write about the concept of isostasy. Basically, you need to remember one thing as far as isostasy is concerned. If any question come related to isostasy, you must write about line of compensation. Suppose this question is asking only about level of compensation, right? But you can write about the line of compensation also, the level of compensation also, and the zone of compensation also, along with all the names. That is, the line of compensation was given by George Airy. Then Hafford and Bobby talked about the level of compensation, and the zone of compensation. Sorry, zone of compensation was talked by uh, Airy, whereas line was talked by Pratt. So like this, you can write about the isostasy. So this was comparatively technical question, but this can be prepared. This can be prepared after you prepare a structure of 200 words. This is a very much doable question because the questions related to isostasy is direct, and you can use these examples like Three Gorges dams, etc. So to modify you or to substantiate your answer. Okay. Now let us look at the sixth question. Again, the question is of 15 marks, and you have to write in 250 words. So let us discuss this question. The question is, discuss the various paleoclimatic and paleomagnetic evidences of continental drift. So before jumping into this question, we know that continental drift hypothesis was given by Alfred Wegener in the year 1912. He wrote this in his book, The Continents and the Ocean, The Origin of the Continents and Oceans, which was translated in English in the year 1924. So only after that the English world knew about the continental drift theory. So basically, he talked about the climatic and paleomagnetic evidences, and his focus was more on paleoclimatic evidences. So we'll look into all these aspects, that what were the paleoclimatic evidences which were provided by uh, Alfred Wegener. But if we talk about the paleomagnetic evidence, then one theory comes in mind, and that is of polar wandering. And as far as polar wandering is concerned, uh, there is dispute that who gave this apparent polar wandering theory, but one name comes is Creer et al. Creer et al. So we need to focus on this because it is kind of a disputed name, so we will not use this in the examination, but we will write about the Alfred Wegener, obviously. Then, if we have to talk about, so first we will write about the continental drift hypothesis in the introduction, that it was a, a landmark event or a watershed event as far as the thinking about the interior of the earth or plate tectonics is concerned. So first we will write about the paleoclimatic evidence. And in paleoclimatic evidence, the first term is glacial striation. Now, what is this glacial striation? We know that glaciers are moving river of ices. So as this ice moves, there is basically, suppose this is the surface where this ice is sliding. This pieces of ice is sliding. So after it slides and the glaciers is all melted, there will be scratch marks in the surface because of this movement of mass of this ice. So that is glacial striation. This scratch marks is basically striation. So when Alfred Wegener saw these striations, He said that how come glacial striations can be there in the tropical belt of Africa and South America? So they must have been at some location where there was ice ages. So he suggested that when Africa and the tropical belt of Africa and South America was in temperate belt, there was basically glaciers in those regions. And he studied the land masses and he provided the evidences that look, here is glacial striation, and it belonged to, and also there was fluvio-glacial deposits which belonged to the Mesozoic and late Paleozoic era, that is 200 to 300 million years from present. So he said that there was presence of glacial striations. So Wagner rejected the idea of climate change, but his focus was that climate change was not happening. No, 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 it is not cyclical. Rather, continents were drifting. Continents were floating over liquid oceanic plates. What was his idea? That continental plates are solid and oceanic plates are liquid. So he was saying that when continents were floating, at that time glaciers were there in the tropical belt of Africa, South America, India, Australia, etc. Okay, so like that he gave paleoclimatic evidence. So you need to bring these two keywords, glacial striation and fluvio-glacial deposits. Then, okay, one challenge will be there as far as this question is concerned, that the question is very specific and you need to provide keywords as well as the uh, the names of the basically different types of phenomenon, because the content is less and you have to write it in 250 words. So that is the challenge as far as this question is concerned. So you can write that how Wagner suggested that there was drifting of continents, there was presence of this glaciers, etc. You can write about the era. That's how you can attempt this question. Okay. And again, you can reverse this, because Wagner, you can write about this that he rejected the idea of climate change over the years because of the age of the temperate region coalfields and glacial till evidences of the tropics are the same. So this was his idea. After that, you can write about paleomagnetic evidences. And in paleomagnetic evidences, we can write about the mm, polar wandering. Okay. Here you can write about polar wandering, because one thing related to polar wandering is magnetic dip or magnetic inclination. Now, what he said that when magma cools and solidifies into rock, it becomes magnetized in the direction of magnetic north and south. This is basically dip angle, that is magnetic dip. So he said that this angle is changing. This angle is changing, this magnetic inclination is changing. It means there is wandering, and this wandering is happening because the continents are drifting. So he said that magnetic anomaly where the magnetic axis and magnetic dip angle preserved in the rock does not match the latitude of the place where the rock is found. That is basically where it should have been. It was not there if you look at the paleomagnetism. It should have been at a particular angle, but rather we are finding it at another angle. Now, why this is happening? Because there was a drift, there was a rotation of that particular continent. So this you need to explain in case of paleomagnetic evidence. Now, suppose there is dearth of uh, evidences as far as this question is concerned. So how you can uh, approach on this question? Your approach should be you can write about other evidences as well. That along with this, in continental drift theory, Alfred Wegener talked about various fossil evidences. You can name various types of fossil like Lystrosaurus or Mesosaurus, Glossopteris. Okay, so like this you can enrich your answer as far as this question is concerned. Okay, now let us move into another question. So the seventh question is of 20 marks, and this question you have to attempt in 300 words, and there is no dearth of material or resources as far as plate tectonic theory is concerned, because most of the time we start our revision of optional through geomorphology only, and plate tectonic theory is the favorite area. So let us attempt this question. Plate tectonic theory is the most recent concept which helps in explaining the mountain building process. So in plate tectonic theory also you need to look into different types of mountains. That is, what kind of mountain will be there as far as continental convergence is concerned, what kind of mountain will be there as far as continental oceanic convergence is there. So here we have to write about the mountains only. So we'll write about the convergent boundary. Although some can say that we can write about the ridges also, because they are also like mountains, but it is better to stick on mountain building process or orogeny. Okay, orogeny. Now discuss the various mountain building interactions that take place along plate margins. Now let us look into the question. So obviously the plate tectonic theory explains how mountains were formed, and it is widely expected by geomorphologists as well. Here, if you want to flaunt some names, then you can write that plate tectonic theory was given by Mackenzie and Parker in the year 1967. So like this, you can bring various perspectives as well, or name of the geographers as well. So that's how your answer should be there. Also, along with this, you need to draw diagrams. Diagrams are very much important as far as this kind of questions are concerned. So diagrams and names of the mountains, the names of the geographers will definitely enrich your answer. Okay. So it is the result of plate convergence. This we already saw, and involves sedimentation, deformation, metamorphism, igneous activity. This is basically what we are doing here. We are only enlarging the answer, but you can write this in crisp manner only. You can directly address this type of question. This type of question you must have prepared. So that's why it is better to stick on the question rather than moving around the bush. Okay. Then let us look at the different types of convergence. Ocean-ocean collision, that is two oceanic plates. Then ocean-continental collision or convergence. Then continent-continent convergence, and continent arc convergence. Convergence of continent and arc. So first we know Himalayan situation, fold mountains. Here you can say that fold mountains are being formed because of continental convergence. You can write, if you are writing about Himalayan situation, then you can write about the period as well, that this is a young fold mountain which was formed in the tertiary period, that is around 60 million years ago. Okay, but better to write this as an example rather than in bracket. You can directly write collision or convergence, where two continental plates converged, and since these plates were lighter, so there was only one option, that is to go upwards, and hence mountain building or orogeny started. So orogeny should be your keyword because mountain building has already been asked. So you can say, you can write about the different stages, that first geosyncline was formed, then there was sedimentation. Along the sedimentation there was formation of after the sedimentation there was lithification. After lithification there was movement of plates. Okay, so as the continents come closer, the segments of the remaining oceanic crusts are deformed, overthrusting happens, and there was a squeeze between converging plates. Then rather than writing this, you can simply write that how continent-continent convergence happens. You can write examples. Here, rather than words, diagrams will play major role. It is better to explain through diagrams. You can draw diagrams and then write sentences. So for each diagram, you can write sentences. You can write, if you are writing about the examples, then write examples of Himalayas, Alps, Urals, Atlas mountains, because these are young fold mountain. Urals are basically old fold mountains. You can write about young fold mountains and old fold mountains. Okay. Then after this, you can write about the continent ocean collision. And in case of continent ocean collision, there is basically formation of cordillera. And how this cordillera is being formed? We can write about the Andes mountain. Here, the case of Andes mountain will come. Now here what will happen? Before subduction, there will be crumbling in the continental plate. So there will be automatic upliftment. The syncline, geosyncline, geocline will the sediments that has been accumulated will get uplifted. After this upliftment, there will be basically you can directly jump into this point that this marine sediments which is going down along with oceanic plates. Suppose if we draw this diagram, continental plate and oceanic plates which are subducting. So here this warping first happens. Along with this, there is breakage of this oceanic plate, and then there will be formation of volcanoes. So while you are writing about the Andes, that there is formation of Andes or Cordillera, you can also draw a diagram of South America, Western Cordillera, Central Cordillera, Eastern Cordillera, like this. Andes is present in the South American continent. So like this you can draw. Okay. After explaining all the process, also you can write about Rockies, you can write about Appalachian, and this we have already seen. So all these are Cordilleran type of volcano. Here this diagram will be important along with the explanation. But since you have to write this in 300 words, better to stick in 50 to 60 words. That is 3 to 4 sentences in each type of um, orogeny, each type of mountain. Then we will move into the ocean-ocean collision. And in oceanic collision, there will be formation of island arc, because we know that if two oceanic plates are there, and if they are interacting, then what will happen? Here there is water. What will happen? The heavier plate will subduct. And as this heavier plate will subduct, again there will be accretion of sediment. And along with this accretion of sediment, there will be formation of first volcano. Okay. And if there is further enlargement or further subduction, then here there will be formation of island. So volcanic islandic arc will be formed as far as ocean-ocean convergence is there. So you need to elaborate this process, that how ocean-ocean convergence is happening along with this diagram. And here you can give example of various volcanic arcs like the Japanese islands, or you can give examples of this mm, Japanese island is a better option. Hawaiian island is basically hotspot, so better to stick to Japanese islands. Okay. Then you can write about the continental arc collision. Now already arc is being formed. Now you have to write about the continental arc collision. And in continental arc collision, basically you can write example of Australia and New Guinea. Okay, that already a volcanic arc is there, their subduction is happening, so again there will be creation of volcanic islands. Okay, but and also wherever subduction is happening along with mountains or islands, you need to stick basically on mountains, but a volcanic island can also be created, which can be enlarged up to a level of mountain. So after that, you can write that this Australian counterpart, or the New Guinea region is being formed. This has been rejuvenated, and that's how you can conclude your answer, that plate tectonic theory explains the formation of different types of mountains through its convergent boundary. Now let us look into the eighth question, that is again of 20 marks, and you have to write in 300 words. So the question is, and this is a very technical question, if you dwell into the formula side of Thorndike, then this will become one of the toughest question. Better not to think about the formula given by Thorndike. Okay, because the question is asking about discuss how the role of rainfall and temperature in delimiting climatic regions evolved from Köppen's classification to that of Thorndike classification. Okay, so basically we have to set the premise that what was the condition on which Köppen was making this region? What was the idea behind or basis of the uh, climatic and classification provided by Köppen? And then we need to move into the Thorndike classification, that how he modified his classification. So the basis of Thorndike classification was basically, Köppen's classification was basically air temperature and precipitation. You can directly start like this, that his basis was air temperature and precipitation, and his idea was based on quantitative as well as empirical classification of climate. So he was basically taking readings as well, and it was quantitative as well. Okay, so, and what was uh, uh, a breakthrough as far as his idea is concerned was he was using shorthand code of letters, okay, to designate various type of regions. In how many groups he divided? Basically, Köppen gave two classification. In 1918, he gave one classification, and then he again added one more group, and in 1931, he gave another classification. And in between, Thorndike gave his classification in 1924. Okay, so basically we have to compare between 1918's Köppen classification with that of 1924 Thorndike classification. Sorry, 1931 Thorndike classification. And Köppen's updation was in the year 1936. Okay, 1936. So basically, after 1918, Köppen updated his classification in 1936. In between, in 1931, Thorndike gave his classification. So in 1918, he was considering this two groupings, two factors, two parameters: air temperature and written preparation. This is not preparation. This is precipitation. Okay, precipitation. So in this year, he was basically thinking about this air temperature and pressure, and on this basis, he made five major climatic groups. Five major climatic groups and two subgroups. That is, he basically divided into A, B, C, D, E, in which he wrote about different types of climate. This is basically A, B, C, D, E. In A, he talked about the tropical rainy climates, tropical humid climates or rainy climates. In B, he talked about the dry climates. In C, he talked about the mild humid climate. Okay, so here he talked about mild winter or mesothermal climate. This is also mesothermal climate. Okay, then in D, he talked about snowy forest, or there was a term microthermal climate. Okay, I think that term is not given here. Microthermal. Oh, okay, it is given here. Microthermal climate. So he talked about the snowy forest as far as this D is concerned, and in E he talked about polar climate. Okay, so basically he was generalizing this. For this this was the shorthand A B C D E that you can map this. So this was the five principal types of classification designation that was given by Köppen. So it was strictly empirical, where each climate is defined according to fixed values of temperature and precipitation. So he used the values as well, 18 degrees Celsius. So rather than writing 18, 8, 10 degrees Celsius, you can write this fixed degree of fixed values of temperature and precipitation. Okay. Then he wrote about the semi-arid and arid desert type of region. So in this way, he provided his classification. So this was the classification of Köppen. Then he also talked about this small lowercase letters, that is F for precipitation throughout the year, W for winter dry season, S for well-defined summer season, and M for monsoon climate. This much you can write in the first part of your answer. Now you have to move into the Thorndike classification, because Thorndike basically updated his classification, and Thorndike classification is very huge. Okay, so he basically created mathematical indices as far as classification is concerned. This much you cannot write in the answer, it is very natural. So let us move into the Thorndike classification. So he gave this classification in the year 1931, and he basically created various indexes, that is thermal efficiency index and then precipitation efficiency index. He also created one more index, that is humidity efficiency index or humidity index. So on the basis of this index, and for this he created formula as well. I think the formula must have been given here. Okay, so this was the formula. The thermal efficiency index, that is summation of T minus 32 by 4, where T is basically mean monthly, this small t is mean monthly temperature in degree Fahrenheit. Okay, this T is mean monthly temperature. It's better not to write this kind of formula in the examination because you will be unnecessarily burdened. Better to focus on the question that you know, but if you have prepared this question, then you can write these kind of things. But rather than writing this, focus on the discussion part. Okay, so how things are getting complex, you can see here. Okay, things are getting complex as far as Thorndike classification is concerned. And what is the role of the model? What we read in models and theory, that we need to simplify things rather than complicate it. Okay, yeah, yes, we know that understanding is required, but simplification is also important. Okay, so from simplification point of view, we can also talk about Trivartha's classification, which was one of the simplistic classification, climatic classification. Okay, so this was about thermal efficiency index. Then he talked about in this only he talked about potential evapotranspiration. That is, uh, why this potential evapotranspiration is happening. This was a new index, and this index was added by him in 1948. Whereas in case of precipitation efficiency, he was again using one formula. I think that formula is also given. Okay, not given. So let me write that formula. It was a comparatively complex formula, that P by E is equal to 11.5 P by T minus 10 raised to power 10 by 9. Now, how can you say that precipitation will happen on the basis of this formula, or we can derive climate on the basis of this formula? So this was kind of mathematical or quantitative revolution. We saw that over mathematization of geography was happening during that period, and that's why there was shift towards behavioral geography. So this is an example of quantitative revolution. Okay, so then he talked about potential evapotranspiration. So on this basis, he made lots of provinces: five humidity provinces, six thermal provinces, four seasonal variation provinces, and if you do permutation combination in this, then 120 climatic regions were derived as far as this provinces are concerned, whereas in reality only 32 are possible. So you can see that only 25% of the region is possible as far as this calculation is concerned. Thus, it was a bit complex, and hence a simplification. Coupons was too simplistic. Okay, we can say that okay, Coupons was too simplistic, but Thorndike was cumbersome. Okay, and hence there was a degree of rigidity, whereas Coupons classification was flexible in nature. So towards the end, we can also say that we can also write about Trivartha. Okay, although it has not been asked, but we can write about Trivartha, that Trivartha made one more classification, and the basis was Köppen's classification. And he gave six provinces. This was one of the most simplistic provinces. He used only two weather elements, that is temperature and pressure. And his scheme also included the effects of land and water surfaces on the climate of an area. And this is more popular among geographers. This Trivartha is, so towards the end, towards the conclusion, you can write that Trivartha's classification is more popular among geographers because of its simplicity. In this way, your answer should also be simple. Okay, so simple answers fetch more marks. Okay, now let us look into the last question. Again, one of the easiest question, and 20 words question. Here, a lot of scope is there to write a multifarious, multifaceted answer. It can go in any direction. Okay, so 300 words answer, and there should not be any strict model answer for this question, I must suggest. Okay, so the question is climate change is a reality. Explain with suitable examples. So I think I don't need to explain this answer, but still let us look at the point. What points are given here? Okay, so the first point is rising global temperature. No doubt, we are breaking record year by year, and we are targeting that we need to uh, um, limit the increase in temperature by 2100. We need to keep it by 2.1 degrees Celsius, but that is not going to happen. We already know. Okay, so like this, you can write that temperature is rising exponentially, and there is amplification, there is Arctic amplification. So all these things you can write that in tropical belt the temperature rise is less, whereas in temperate belt or in polar belt the temperature rises comparatively multiple times more than the tropical belts. So you can elaborate this point very well. Then melting glaciers and ice sheets. Every year we have seen the images of ice sheets. You can write example of T32, A32 ice sheet. Okay. Oh, sorry, A32 glacier in Antarctica. So like this, you can use examples of uh, this current affairs as far as the melting glaciers are concerned. Then increasing frequency and intensity of extreme weather events. Dubai floods is an example. Okay, so flood in Pakistan is an example. California wildfire is an example. All these examples you can use. Heat wave is an example. Drought is an example. Okay, then storms is an example. Increased frequency of cyclone is an example. All these example you can use. Then changing ocean ecosystems. Here you can write about the coral bleaching, that why mass coral bleaching is happening because of the increase in ocean temperature. So marine heat wave is also a phenomenon. And there was one more phenomenon as far as this is concerned, that there was a winter heat wave in Antarctica. Okay, so from the usual temperature, there was 20 to 30 degrees Celsius more temperature in the Antarctica in 2024. So this you can use as an example in uh, from the current affairs. Okay. Then shifting plant and animal ranges. Obviously, we saw that this is happening. Why? Because of climate change. That animals are trying to move toward cooler region. Okay, so that's why they are shifting. They are migrating to cooler areas. Then changes in phenology, and these biological events are changing. Flowering season is changing, migration is changing, hibernation is changing. Lots of things are related to this. Then impacts on agriculture. Obviously, already majority of the agriculture in India is dependent upon monsoon, and that too monsoon is getting erratic. And why it is getting erratic? Because of climate change. So you can link all those things with agriculture, the erratic nature of monsoon, dependence, over dependence on monsoon, and hence what will happen or how it is a reality. Then permafrost thawing, and you must have seen in very various apocalyptic movies that if permafrost will thaw, then various ancient this biologic this bacterias will come out. Okay, so all these things is a reality, and because of permafrost thaw, there is also release of methane and trapped methane, which will again increase the global warming. Okay, then increased intensity. These heat waves we already wrote in this point, I guess. Increased frequency of extreme weather events. So heat waves was already mentioned. Okay, so like this you can attempt this question very much. So there is no need of explanation as far as the ninth question is concerned. One of the easiest question.